Bobcats, this is Mr. Peterson, and this is the first in a series of videos on variation functions. This one will involve direct and joint variation. Direct variation, as you should know already, is a linear relationship that can be written in the form of y equals kx, where k is not 0. You might want to go ahead and pause the video right now to get these definitions jotted down. Lines, of course, have a constant rate of change. Whenever you've written lines in slope-intercept form in the past, any line that you've ever written where b was 0, or in other words, it's just y equals mx, that is a direct variation situation, also known as proportional. Also, direct variation means that your line is going to pass through the origin. And the constant of variation, which is the variable k, is the constant ratio of k to x, or excuse me, y to x. Y to x. All right, so let's look at some problems. It says here that we know that y varies directly as x, and y is 14 and x is 3.5. So write and graph that function. All right, so we know that direct variation is always in the form of y is equal to k times x. In this situation, we don't know what k is. They want us to find it. So we know that 14 is equal to k times 3.5. So we would figure out what k is by dividing by 3.5 on both sides. 14 divided by 3.5 is 4. So we know that k is 4. So our direct variation equation would be y equals 4 times x. And I've already went ahead and graphed it over here. I made a little table. X, y, -1, 0, +1, and we wind up with -4, 0, and 4. If you go ahead and go to 2 and -2, you wind up with 8 and -8. And here is that line on there. You can see that. So why don't you guys try this one? It says graph it, but just I want you guys to worry about picking which one is the right equation. All right, if you're given a situation where you don't know what k is, you can just, like we did in the last problem, plug in the two that we do know and solve for k. Also, it's important to note, and we already mentioned this, that the phrase y varies directly as x is the same thing as y is directly proportional to x. Those phrases are synonymous. All right, example 2, solving direct variation problems. Okay, so the circumference of a circle C varies directly as the radius r, and C is 7 pi feet when radius is 3.5 feet. Find r when C is 4.5 pi feet. All right, so like we talked about, we can just plug in numbers into our direct variation situation and get what k is, which again, remember, it's y is equal to k times x. So in this situation, we know circumference varies directly as the radius, so circumference is what y is. So 7 pi is equal to k times 3.5. So we would divide by 3.5, divide by 3.5. The 7 and the 3.5 all cancel into 2 and a 1. So it's 2 pi, don't forget the pi, is our k. All right, now we're not done. We know that k is 2 pi. The second part of the problem is we want to know find r when c is 4.5 pi. All right, so now we know that this situation involves the equation y equals 2 pi times x, because that's what this first part set us up for. And we found what k is. K is 2 pi. So now we're going to take and plug in this number into this new equation that we got. We know c, which is our y, is 4.5 pi is equal to 2 pi times x. All right, so we would solve by dividing by 2 pi, divide by 2 pi. The pi's are going to cancel out. Everything cancels out over here. So 4.5 divided by 2 is 2.25 equals x. So our radius, when c is 4.5 pi, our radius is 2 1/4, or 2.25, and our units are feet. Feet. All right, so now why don't you guys try this one? give you a couple clues. A dodecagon that would have 12 sides, just FYI. All right, new vocabulary word here. You might want to pause it and write this down. Joint variation is a relationship among three variables that can be written in the form of y equals k times x times z, where of course k can't be 0. And in this we would say that y varies jointly as x and z. Alright, so let's try one. It says the area of a triangle varies jointly as the base b and the height h, and area is 12 meters squared when b is 6 and height is 4. So find b when area is 36 square meters and height is 8 meters. Alright, so we know that it varies jointly. So we know that we'll be using this equation, y equals k times x times z. Alright, and we know that the area A is varying jointly, so area A is going to be what y equals. Alright, so we know that, so we got, again, this is going to be a two-step problem. We know that area A is 12. We don't know the constant of variation, so that's k times 6 times 4. Alright, so we know that this would be 24. So 12 is equal to 24 times k, divide by 24, divide by 24. We know that k is equal to 1/2, which is 0.5. Alright, so now that we know what k equals, we can take it in and use it to help us find this second little bit of information. And again, now what we know that this equation that represents this situation is y equals 1/2 times x times z. So you can kind of see here that the formula for area of a triangle is a joint variation situation. All right, so we know that A, which was our y, is going to be 36 is equal to 1/2 x and z. So that's going to be times x times 8. 1/2 times 8 is 4, so 36 is equal to 4x. So divide by 4, x equals 9. So that means that our missing variable is b. B equals 9 and the units were meters. So there's that one. Why don't you guys try this one, and we will see you in class. Oh, actually, you know what? Hold up. No, we'll just see you in class.